So now let's proceed to Lesson 9, and let's go to our notes packet 1.09, Angle Relationships, Part 2. The objective for this lesson is the same as the objective for the last lesson, to identify and use adjacent, vertical, complementary, supplementary, linear pairs of angles and perpendicular lines, and to construct perpendicular lines. We've got an interesting diagram that we're going to have to answer some questions about. So before we even get to these questions, which is A through H, let's take a closer look at this diagram and let's see what we can figure out about it. Let's see how many things we can write into it using the information that we're given. So we're told, first of all, that in this diagram, line segment AD is perpendicular to line segment XB. Well, the first question you might ask is, we've talked about two lines being perpendicular, but we've never actually really spoken about two line segments being perpendicular. Okay, so this is sort of shorthand. When we say line segment is perpendicular to line segment XB, it means that basically line segment is part of line AD, and line segment XB is part of line XB. So it's really shorthand for saying line AD is perpendicular to line XB. And it's also saying at the same time that we're going to refer now to the line segments instead of the lines. Similarly here, you'll see it says line segment XE bisects angle FXD. And we usually talk about a ray bisecting an angle and not a line segment. But here you'll notice that, again, the same kind of principle is in operation, where line segment XE is sort of on ray XE. So just imagine that we're really dealing with the ray, but we're drawing attention to the line segment that's part of the ray. So let's see if we can notate our illustration to make things a little bit clearer. AD is perpendicular to XB, so line AD and line XB are perpendicular. So we know that two perpendicular lines meet at right angles. So let's write a little right angle symbol there to remind us of the fact that there's a right angle. XC bisects angle BXD. Well, where is XC? That would be here. And BXD is another right angle, right? We could, basically, if we wanted to, lightly write in another angle symbol there. But we're saying that XC is bisecting BXD, so we also need to write in a notation for angle bisectors. So the two resulting angles, the smaller resulting angles, are also equal to each other. So we'll write two little notches to show that those two angles are equal. We're also being told that XE bisects angle FXD. Well, XE is down here, FXD is this whole angle, so we can now create another notation, and notice I'm putting two notches in each angle to indicate that this angle, FXE, is now equal to angle EXD, and each of these smaller angles are equal to 1/2 of the original angle FXD. Why am I putting two notches in these and only one notch in these? Well, the reason is because I know that these two angles are equal to each other. I also know that these two angles are equal to each other. But what I don't know, and I can't really prove, and in fact isn't true, is that this angle with the two notches is equal to the angle with the one notch. That we're not given. And in fact, as we're going to see very shortly, the angles with the one notches are not equal to the angles with the two notches. So if I put one notch in every one of these, then I would be implying that all four of the angles were equal to each other. And that's more than I know. All I know is that these two are equal and that these two are equal, that pairwise they're equal. So that's why the different notch notations alerts me to the fact that they're not necessarily all equal to each other. Well, let's see if we can actually figure out what all these angles are. So Well, we know that this angle here is 90 degrees because that's a right angle. What about these two angles in the upper right quadrant? Well, we know originally the angle before we had the angle bisector, the angle BXD was a right angle, or 90 degrees, and then we know that XC bisected that 90-degree angle. So what do you get when you bisect a 90-degree angle? You get two 45-degree angles. So we know those two angles measure. Well, it's a little bit trickier to fill in the remaining three small angles on the bottom part of this graph. We know these two angles are equal to each other. Well, offhand, we don't exactly know what they're equal to. We also know that the three angles that are all on the bottom side of the line here, angle AXF, I misread that, AXF. Let me show you that again, angle AXF, and plus the measure of angle FXE, plus the measure of angle EXD, all add up to a straight angle, which would be 180 degrees. So we know that those three angles add up to 180 degrees. Now that's another piece of information we might find useful. Can you see in this diagram some relationship between two angles that would help us figure out what at least one of the angles below the line is equal to? Take a moment, freeze the video, and see if you can see it. Okay, so the relationship is that of vertical angles. Okay, so what we can tell from this diagram is that we've got two intersecting lines that are creating a pair of vertical angles that are helpful to us here. So line AD, the horizontal line, is intersecting line FC, which is this line. And therefore, this 45-degree angle here, CXD, is vertical to this angle here, AXF. Okay, take a look. Try to not see the other lines involved. And kind of draw this by showing you that, in a way, we've got line segment AD, and we've got line segment FC, and we've got a vertical angle here and a vertical angle there. Okay, so let's look back up to here, and it may seem more obvious now. So if these two are vertical angles, then this angle has got to be equal measure to the other vertical angle. It has to be 45. Okay, so we are almost done. We've said that these three angles add up to 180. We don't know what these two angles are. Let's call them Y. Okay, and what we do know is we know that 45 degrees plus y, which is 2y, has to equal to 180 degrees because they add up to a straight angle. And now we can solve for y. We can subtract 45 from both sides. It gives us 2y is equal to 135 degrees. And we can divide both sides by 2 to get y is equal to 67.5. Okay, so now we know y is equal to 67.5, and by knowing that, we can fill in the rest of our angles, 67.5 degrees and 67.5 degrees. Okay, so we're going to use these angle measures in the next video, along with the relationships that we've observed, to complete our questions.